Hello there. Today we'll be doing our 38th problem, 3-sum. This particular problem is a continuation of 2-sum, if you can see the pattern that is there. So um, what we're going to do is that we're going to take the first number and use the 2-sum method to get the negation of the first item, because the negation of the first item plus the two other items, if they are equal to the negation of the first item, means that it is equal to 0. Okay, so that was the overview. Let me explain the problem now. So in this problem, we're given a numbers list, and we're supposed to find all the possibilities, all the ways that we can get 0 from 3 numbers. Okay, so what does that mean? That means if we take the first number and we take all the possibilities of the other 2 numbers, we can add them up and get a particular output that is equal to 0. And what is that output? So what if I took the 2 numbers, add them up, and it was 1? What would it take for me to get for the target if it was a -1? If the first item was -1, then that would become 0. So the negation of the first item is equal to the other 2 items. And with that, we can do the 2-sum method on this 3-sum question, taking the first item as our target. Our target is going to be the negation of the first item. And so basically it means that we're going to create a results, and we're going to sort our numbers so that we can perform the process that we wanted to do. So for I and target, it is enum of numbers. So one thing we want to check before we keep going is that we do not want duplicate triplets. And that means that if I is greater than 0 and target is equal to nums of I minus 1, we need to continue because we do not want to reuse the same item in the same spot twice. That would just lead to duplicates, and we don't want that to happen. So with that, t is equal to the negation of t. And we're going to set our left and right pointer to equal to the I plus 1 and length of nums minus 1. And while left is less than right, we can now go through the sum is equal to sum like left plus nums right. And if the sum is less than the target, as before, left plus equals 1. Else if the sum is greater than the target, right minus equals 1. Otherwise, we found our our equivalent, and we can now append that particular item to our our set. So result.append nums, the target, the nums L, and the nums R. And we need to keep going because there might be more items, but while left is equal to right and nums L is equal to nums L, we don't want to repeat that particular number, so we're going to keep going until we get a different number, and then we will move our right index and get all the possible triplets. So we return the result. Oh, syntax in. Run the code again. Okay, 3 arguments given. That's not good. Well, run the code again. And we have an error. Let's see. Aha! This is not good. How about nums I? Because we don't want to restore the negation of it. We want to keep the number in that particular place. And now we have the answer. Very good. With that, I think that answers the question of how to solve this particular problem. If you check out Neetcode, he has a different way of thinking about it. He just removes the target. You don't think of it as a target. You think of it as a starting point. Let's say starting point, st. And this way, we take the starting point, and we add these three numbers, and this is our three-sum. And we check if the three-sum is less than 0 or greater than 0, or less than 0 and greater than 0. And then we add the three numbers together. So this is going to be our starting point. And that's it. So run the code again. It should work just the same. Oh, yes, st. Oh, run. Okay, we have duplicates right now. I don't know what's wrong exactly. Let's see. So three-sum is equal to 0 at this point. I think I know what's wrong. So this is what's wrong. So three-sum has to equal 0, right? I mean, but does that change anything? I don't think so. I don't actually know what's wrong here. There doesn't seem to be anything wrong. I'm trying to figure out right now. And I see. I see what's wrong. This is supposed to be 0. This is our target, and this is our three-sum. Run. Okay, this is supposed to be st. Perfect. I think that should solve it. And we should submit and to make sure that this is the solution, and we are good. And that is how we can think about this particular problem, three-sum. The one way I suggested was to take the first item as our target, and the negation of that target is our target of the other two numbers. And once we get that, we can append those three numbers together, and we can shift these items across the both sides until L and R passes each other, and we get all the triplets for that particular number, and we keep shifting the target, looking for at each target and moving the left and right pointers to match up with that target. The other way to think about it is as a starting point. If we use this as our first item, the point of which we start, we can start at this particular point and take the left and right items and just work with that left and right item and look at every starting point, which is O of n, and L and R is another O of n, so it's n squared. So that's how we can look at this problem. Those are two ways that I can think of right now. And if you have any questions, please comment below. If you enjoyed the video, like and subscribe. And if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.